Well, let's take your time, come up here. Welcome back. Mike, thanks. Please have a seat. Well, actually, because I had to go over to a press conference to introduce or announce our new consumer guide. I missed part of the presentation by a couple of our speakers, but I came back just in time to hear Professor Lee and also Kevin mentioned about the IPv6 only concept. And I was joking down there with Geoff that, hey, maybe our next year for June 6th, it might be a reverse IPv6 day, which means that turn off IPv4 for one day. And then the year after that, we can have a, I don't know, permanent turning it off. I think I'm dreaming. But what do you think about the idea? I mean, where are we going from here? Just want to maybe give a round of response from our panelists first, and then we'll open up for some questions. Where are we? I mean, today, I mean, we're looking at IPv6 launch, World IPv6 launch today. I think we're seeing a lot of positive things coming out of it. But then when I was talking to other people, like I was talking to the press during my break over at the press conference, people are very skeptical still, particularly some of the numbers we get from the public in terms of their awareness and their perception of how urgent it is to adopt. It's still a little bit not so satisfactory yet. So where's the gap? Because we're seeing a lot of positive things from our community, but the public seem to be not there yet.
The reason why we did it last year was actually because even up to as late as last year, if you turned on V6 and ran V4 at the same time, it was highly likely your experience would be worse than if you were just running V4. And the issue was twofold. One, Windows was doing an awful lot of auto-tunneling, and that was really bad. And secondly, a lot of the providers were really concerned that if they turned on dual stack and their competitors didn't, customers would see lousy response from them and immediately move. So the idea with World v6 Day last year was actually trying to eliminate that sort of competitive loser issue. That I turn on V6 and everyone sees my site is actually lousy, but everyone else has a good experience in staying in 4. The other thing it did, which was really interesting, is that if you've upgraded your software any time in the last 12 months, things are very, very different. Because these days, on everything, actually except Windows, V6 Day has actually improved the dual stack performance. Because these days, we're actually doing stuff in parallel. So last year, we were concerned about content. This year, we're trying to force the issue with access. And access really is the problem. The reason why the numbers are so small in terms of folk preferring V6 right now is probably because it's the access networks that are our biggest problem right now. And I'm still not sure what the appropriate answer is there. There are some tough business and economic issues to solve.
Michael and Kevin? Kevin?
Yeah, so I think it's going to be hard to, have some event like IPv6 only, just turn off the IPv4 in near future, probably, next 3 to 5 years. But I think we need to advocate sort of for any new application or any new website or new subscriber from service provider, we need to emphasize more on how about just do the IPv6 only, because that's something new then, right? And as I also talk with the content providers, always like this, can you try for your new application, then, right? you just do the IP one stack, one network, just do IPv6. Then let's the service provider, let's, to provide solution, at least, you will say, okay, I still, can provide service to all the subscribers. Doesn't matter, it's IPv4, IPv6, the private IP. Because I think we need to decouple the challenge for the content provider, because otherwise, it's really confused them. Because when I first talk with the content provider, I say, hey, you need to do the IPv6. He said, okay, I need to talk with the service provider first. Then when they talk to the service provider normally try to solve the problem from access. Holy mackerel, because they say, oh, we're going to do the private IP, which is with dual stack like, and the IVI, there is a ton of technology, 6RD. The content provider just amazed, huh? So what they will do, they were very confused, because they said, okay, if you do some technology, you're going to follow the ISP. So that's the problem I say from us, because they are not that deep.
Well, it's not their business. It's not the business of the content provider to worry about so many of these dual stack and all these problems, right?
Yeah, so I think we should decouple, basically say, hey, you just provide the new content, then let the service provider solve the problem. Whatever, dual stack, whatever, right? As far as you have no problem to reach your customer. Doesn't matter about that.
But if the content providers are going to be providing V6 only content,
only new application, because
only new applications,
yeah.
But even at that, that means the support from the operators, from the telcos, needs to be at least able to allow them to have these new services being reachable by the V4 clients. So,
exactly.
So you need to reach a certain minimum level of support from the service providers first, right?
Thank you. I think this concept of competitive advantage is an interesting one. And I see a parallel in that with the way the browsers began to adopt IPv6 in preference to IPv4. And we'll see, I'll keep talking. This concept that if you had an IPv6 site and an IPv4 site, and you wanted to reach it using a web browser, the web browser initially, over the last few years when it was first introduced, whether it be Firefox or one of these other browsers, would make the call as a V6 call first, and if it didn't get a response, it would then fall back to IPv4. And this caused some delays because there was this timing issue where it was waiting. If there was no V6 service out there, it would cause a delay and would wait to come back. So they ended up with a parallel approach now, a kind of ships in the night approach, where both protocols are attempted, and whichever one recovers first or actually gives you the response first, that's the one that you actually connect to. So that's an opportunity of actually looking at the reality of what you're attempting to do on the network. And for me, that's the parallel with IPv6 deployment. I don't see IPv6 adoption being driven by doing the same thing that happens in IPv4, because IPv4 does it very well. And so there is no inherent advantage, and in fact, given packet sizes and latency and a number of other issues, there are some inherent disadvantages to perhaps doing some things in V6 compared to V4. In my mind, what's going to drive it are the scale and the adoption of new technologies, and being able to do things that were previously impractical or very difficult to do. And so I think we'll see more and more adoption of vehicle-to-vehicle communications, of the Internet of Things, of sensors and lights and different autonomous systems being brought into play through the use of IPv6 and new services that are going to be deployed. And that will drive the adoption of V6 into the future, and that those services will eventually get to the point of paying this dual stack tax issue that Kevin raised, will actually then drive the eventual adoption of IPv6 in preference to IPv4 as time rolls on. Now, the disadvantage of that strategy is that it's a long-term strategy, and it will take some time to achieve. So I don't see us turning off the IPv4 network anytime soon.
Okay, any question from our audience? Usually someone just need to ask the first question and then they keep coming. No? I see a hand back there with the gentleman back there. Can we get a mic to that gentleman in the back? It's coming.
Hi, my name is Yusuf Faisal. I'm from Verizon Business. I have a question. I have two questions, actually. The first question is to Mr. Geoff. You mentioned in your speech that we made a mistake with IPv4, and now we realize it, and now we are turning to IPv6. My question is that are we making another mistake by turning to IPv6 or not? We did solve a problem for the address space and did solve the problem with the security piece, but you know, there's other issues for IPv6 in terms of security. So how do you see that we have solved the problem? And if we have, like, why do you think that we have solved the problem? Second question is that for all the panelists, is that what do you think in the coming years when IPv6 is the choice of the protocol, internet protocol, how would it benefit socially to the general public? Thank you.
You know, this is not the first time we've changed protocols. It's just that very few of us were on the internet when we did it the last time. Because the last time happened on the 1st of January in 1983, when we moved from 8-bit addresses using NCP to 32-bit addresses using TCP/IP. Interestingly, we expanded the address space by a factor of 4. And interestingly, we were so small that we could do it overnight. We're going to expand the address space again by a factor of 4, which seems about right. Why? Because any larger is just insanely large and actually hard. And any smaller seems to be a bit too small. So in terms of what have we changed? Not a lot, just enough. Does it make issues like security any different? Not really. There's only one difference. There are two ways to get infected these days. One is by putting in an already infected USB device. By putting something on your machine that's infected, you get infected. The other way is drive-by infection, where someone casually scanning the address space knocks on an open door and you're running, probably Windows XP, you've left port 445 open, you die. You can't scan N6. It takes more than the life of 10 universes to even get past a /48. So in terms of the infection vectors, yes, 6 is different. Probably a little easier for some of us, and certainly not quite as toxic as 4 has become. But that's a small part of it. The rest, most infections, most viruses, most malware happens at the TCP and UDP level, one level up the stack. And what we're talking about here is not changing the universe. We're not changing every application. We're actually changing very, very little. Just IP, just the bit at the bottom. So the malware in TCP, the malware in UDP, you can keep on having as much fun as you were having yesterday. In V6, nothing changes. Same old story.
I probably can add a little bit because I deal with the Chinese research community. So there is always a big question, say, okay, you know, IPv4, IPv6, it's all invented by US company. So China, we have a big market. Why don't we design new protocol? You know, I don't know if you heard it or not. IPv9. So, you know, they convince the government to funding those kinds of things. Be honestly, I think the protocol, just like a language, is agreement there, right? So two of us in the dark room, we can create new protocol. It's not hard. But it's hard. We are looking for the one network language for all the industry. So that means that protocol probably not perfect for particular application. Because everyone say, for this application, I can design much better protocol than IP. Truth is, that's a small market. So if you have some advantage for the new protocol to solve one problem, you probably create 10 problems for other applications. So that's why internet success driven by market and by industry. So far, for my, sort of the 10-year or 5-year, 10-year visibility, it's just so hard to design the new, another perfect protocol to replace IPv6. Security is another argument, especially in China. A lot of people say, oh, there is a lot of problem for the internet security. One guy said, we can design the security mechanism perfect. No spam email, no, all the source of the address is authenticated. So, I run into the problem always with the government. I told them, I say, internet just like a human society. If you control each person for each day, their schedule, where they're going to go for next hour to report a central authentication mechanism, you can design that system, but you kill much more stuff. So that's why I think, the research community always try to invent something new, but for the industry continue to grow, probably for next 10 years, IPv6 is the only option there, because as Geoff said, we already know it's going to work for most of applications. There is a problem, but we use the toolkit, fix problem through the industry consensus. It's not easy, but if you're born in the ocean, say, oh, let's change something else, I don't bet that.
Michael?
Well, actually, I think the question was actually addressed to Geoff, but I'll comment anyway. And a couple of fundamental things. One is, I'm not sure that Geoff actually said that we made a mistake with IP version 4. I think he said the mistake was that we didn't go to IP version 6 quick enough. And the issue there is that I think that at a couple of different levels, IP version 4 has actually stood us in very good stead. It's a protocol that's lasted over 30 years. I don't think there's any other protocol in the IT industry or anything that lasts more than 6 months. So, there's always some new version, some new device, some new service. So to have a fundamental structure that's been in place for 30 years, I think is a testament to its power. And if IPv6 lasts as long as that, I'd be A, surprised, and B, very happy that we've actually struck the right answers for the sorts of questions that are coming up. There are some fundamental changes in IPv6 that are sometimes glossed over as not the right phrase, but are sometimes, in my mind, not to be overemphasized, but there are some fundamental changes that change the structure of some of the things we're doing. Some of the things like the embedding of IPsec protocols into the headers, for example, or the capability of doing authentication and encryption as IPsec as part of the service. The fundamental change in the way that we're using multicast to actually provide services in IPv6 is actually different to the way that we do it in IPv4. There is no ARP, there is no layer 2 calling service in IPv6. It's done using multicast, various combinations of multicast services. There are some architecturally fundamental changes that were designed to improve the IP protocol and to enable it to be adopted in a service, the alignment on 64-bit protocol limits. There's a number of different areas that have been brought to enable some services that come into play. I'm a great fan of mobile IPv6. There are many who aren't, and that's a separate argument that we can actually talk about. But there are some fundamental protocol changes, and so architecturally, there's some things. The 20-bit flow label, for example, which we are still struggling to find a good use for. But I am optimistic that there will be tremendous uses for that. So there are architecturally fundamental differences between the protocols, and it's worth us all, not necessarily at a consumer level, but all of us as adopters and implementers, it's worth us taking the time to understand what those changes are and to take advantage of them as they're presented to us. So,
but Michael, it's precisely those changes that engineers have the most problem with, oddly enough. You know, the issue around changing the way fragmentation behaved all of a sudden brings up a massive number of problems because we fell into this trap of thinking ICMP messages are bad, evil, filter them out. All of a sudden, if you do that in 6, badness happens. None of us understand multicast. It is a disgustingly complicated thing to do, even at a LAN. And now, all behavior that happens on a LAN now happens with multicast in 6. This is tough stuff. And then we started mucking around with MTUs, not to mention the flow label. You know, a proposal to change V6 has to put stuff in the flow label or it's not real. You know, so oddly enough, the bits where we engineered more are actually the bits that cause engineers the most trouble right now. And the one thing we did, I think, quite critically right was just the address size is fixed, not variable.
Yes.
It's fixed big, but it's still fixed. And that's the one thing I think that we remembered from 4 and applied into 6 cleanly and well. The rest, oddly enough, I could take it or I could leave it. And most folk who struggle with 6 to put it up have problems with precisely those areas that have changed. So a mixed bag at an engineering level.
I think we're getting into chapter 1 of the history of IPv6 already. Any other question? I think in view of time,
Sorry,
we
Charles.
might be able, oh, okay.
I think that guy had one
You
more.
got a follow up?
Yeah.
Yes. Okay. Do you have something?
No, I just wanted
Yes.
to say thanks.
Okay, thank you. Let's see if we have time for one more question. I gotta get you back on the bus. This gentleman in the back here.
My name is Liu Ziang. I'm from mainland of China, and I think the most important thing is not about the technology, but about delivering the correctness and the proper conception of IPv6 to the customers, because customers are getting used to the old things and the concepts, and what you say is just make us confused and think IPv6 is change of IPv6. I don't think so. So in my opinion, the most important thing is about give the IPv6 a new concept, not a change of IPv6. Is my opinion, and I want to. What do you think?
Well, you're younger than any of us. I think it's easier for you to change than any of us can. But Geoff.
100 years ago, we started electrifying our cities. We started to install a big generator. I think you can probably see one outside there. And reticulate electric wires throughout the city. And oddly enough, it wasn't done the same way. Some cities used direct current. Others used alternating current. Some cities used 50 volts. Some used 100. Some used 600. And a lot of debate in engineering circles 100 years ago was all about what was the right way to do power. None of us talk about it anymore. We've kind of figured that it's alternating current. We've kind of figured that 50 to 60 cycles is okay. And between 100 and 200 volts is sort of all right, so none of us talk about it anymore. The most successful and enduring technologies disappear. They just become part of our life, and we stop worrying about them. But until we get them right, there's a big debate. There's a lot of talk. There's a lot of concentration. So 100 years ago, it was all about whether the current should alternate or not. And right now, we're having a debate about what bit should be in the packet header. And I'd like to think that we're pretty close to getting it right. And if we do, that's the end of the debate. It'll just disappear, and all the silicon, all those 10 billion processors we make every year from those silicon factories, will just have this built in, and we'll move on to talk about other things. And that's natural. But why are we talking about it now? Because it's still a problem right now to figure out what's the right way of doing it. What will endure and disappear?
Well, actually, I just want to add that I think the IPv6 only generation may start within a couple of years from now. I mean, young kids at 1 or 2 years of age, in 5 years, they first get onto the internet, and to them, IPv6 is the only thing. And then we got to talk about telling them whether or not they need to worry about backward compatibility and so on. But Steve Jobs tells us that don't worry about that, right? So I think actually the switch would probably end up to be easier than we could imagine. What do you think, Michael?
Oh, just a comment. I mean, there are IPv6 only websites now. There are even IPv6 government websites in India and other places.
Yeah, in Hong Kong too.
Where those services are only available through IPv6.
Okay, not only yet.
Yeah, and there are certainly gaming servers and all sorts of private stuff that's actually out there that is V6 only now. So we certainly need the capability of being able to get to it. It's just that it's such a small percentage of the overall market that we still need that dominance of being able to support IPv4. But I think the point you make is a good one. The end user is less concerned about the technology and finds all these different choices confusing. Would much prefer to be just handed the solutions on a plate by their ISP and by the services that the supplier, Cisco or whoever it happens to be, that are actually there. The truth is that in most cases you'll be safe and you'll be taken to a good place if you actually follow that, but occasionally you won't be. And occasionally you'll be perhaps tied in, there may be vendor lock-in, there may be service supplier lock-in, there may be issues about you not being able to take advantage of something that some other person is actually providing further down the line. But I think Geoff's right. We're at the point now where these are future problems that will occur, and that it's more important for the people who are deploying this technology now to actually take their customers forward in a smooth and easy way. So I think the point you make is a good one.
Do you think it's worth?
Sorry?
We spend so much money and time on it. It is worth. Is it worth to do this thing?
Is it worth to do this?
Oh,
Yes.
Oh, yes.
And you think right, it's just a specialist think it's right, but customers don't think so. Maybe they just want good things, not better things. They just want want it to be suitable.
There is a continuous issue in this industry between the folk who carry the bits and what the bits are. Carriage versus content. And for the last 100 years, the carriage folk dominated this industry. One of the largest enterprises in this town was Hong Kong Telecom. One of the largest companies in England was British Telecom. They were the giants and they were carriage providers. Content only happened if they said so. And over 70 or 100 years of the telephone, the only innovation you got from those folk was a fax machine. That's as far as they ever went. In the last 20 years, life for almost everyone on this planet has changed amazingly. I have maps of the world in my pocket. It'll tell me where I am on the globe second by second. I know weather, I know flight schedules, I know messages. All of that happened because the internet changed the equation and told the carriage providers that their days of monopoly dominance were over and content ruled. Google is a valuable company because people want content. Now, if we continue in V4, I can't promise you that will continue. In fact, I think I can promise you that the opposite will happen. Because if you try and make V4 stretch across hundreds of billions of devices, the only way it's going to happen is if I restrict content, if I populate the network with application-level gateways, if I change the internet to be a lot like the telephone was 20 years ago. If that's what you want, fine. But I don't want that. I want this to continue. I think the last 20 years has been exciting, different and innovative. And I think you're all here for the same reason. If we want open networking, if we want content to rule, if we want that excitement of doing something different, that you or you or you can develop a new Facebook tomorrow, if you want that, you really need open networking. And the only way you're going to get that is by having open architectures. And the only way you're going to get that on a massive network is with V6. Is this important? It's the most important debate we can have right now, because we're talking about the future of the entire internet and everything with it. So yes, it's worth the time, it's worth the study, it's worth the attention, because this is everything.
Okay,
just a quick comment. The business as usual is broken. We cannot continue the way we are on the networks that we have, and we have no alternative but to go to V6. So there is no do-nothing case, right? We have to move forward with this. There's just no other choice.
Final words, Kevin?
Yeah, in addition, the new connected device I mentioned about each year, like 300 to 500 million devices connect to the network. So that's the business case driving us to new internet language. In another area, just Internet of Things, I think that's a absolutely new domain. So we know we need to connect to the one network because we can leverage a lot of application and toolkits. But how the new innovation going to come out from that? You know, smart grid, smart meter, smart load, those kind of things. We don't even know yet. That's why there's a huge space you can innovate by using the IPv6. And I will assure you, the people will innovate in that domain. So that's the hope. We will move to the IPv6. Just in the next 2 years, you will see the difference.
Okay, I think we run a bit out of time, and let's all have a round of final applause for all our panelists and speakers. Thank you.
Thank you, guests. Please stay behind and take a group photo together.